Welcome to YouTube channel Han Tech Sword. Today we will understand the concept of current, voltage and power. This is very basic knowledge about electrical and we will see that how current, voltage and power are related with each other. Let's start with the current. In simple, current is the flow of electrical charge. To understand current, we need to understand the flow of electrical charge. An electric charge must have either negative or positive polarity. An electron have negative polarity and proton have positive polarity. Charges of opposite polarity attract each other by the force of attraction, and charges of same polarity repel each other by the force of repulsion. Now, let's have a look at atomic model. In center, we have positively charged protons and electrically neutral neutrons. Negatively charged electrons surround nucleus in different orbits. Due to force of attraction, nucleus held electrons more tightly in inner shell than outer shells. Now, the electrons which are moving in the outermost orbit can be easily flow out using little amount of energy, and this outflowing electron contribute in the flow of charge. Charge is a quantity of electricity. The charge is static electricity at rest without any motion. Unit of charge is coulomb. The symbol for electric charge is capital Q or small q, standing for quantity. 1 coulomb of charge has 6.25 into 10 power 18 electrons. Now let's talk about the concept of current. We have a piece of copper wire and electrons are flowing through this copper wire from battery to LED. We want to find out that how many electrons are flowing through this wire. Let's assume that 1 coulomb of charge is passing through the wire in 1 second. Then we can say that current which is flowing through this wire is 1 coulomb per second or 1 ampere. Now, current can be defined as the rate of charge passing through a reference point in unit time. Current is measured in ampere and it is denoted by symbol I. The symbol of current I indicates the intensity of electricity in motion. Since the current is a measure of how intense or concentrated the electron flow is, 2 amperes of current in a copper wire is a higher intensity than 1 ampere. A greater concentration of moving electrons results because of more electrons in motion. Sometimes current is called amperage. The charge is static electricity at rest without any motion, and the current is the flow of charge in unit time. The difference between electric charge and current is similar to the difference between kilometer and kilometer per hour. Potential refers to the possibility of doing work. Any charge has the potential to do the work of moving another charge by either attraction or repulsion. When we consider two unlike charges, they have a difference of potential. Assume that a charge of 1 coulomb can move 6 electrons, and we have 1 coulomb of positive charge at positive terminal of battery and 1 coulomb of negative charge at negative terminal of battery. Due to the force of repulsion of negative terminal and force of attraction of positive terminal of battery, we have potential difference of 12 electrons between two terminals of battery. Volt is a measure of the amount of work or energy needed to move an electric charge. So let's assume that we move 1 coulomb of charge from negative terminal of the battery to the positive terminal of the battery with the expense of 1 joule of energy. Then the potential difference between two terminals is 1 volt. It may be helpful to think of voltage as an electrical pressure or force. The higher the voltage, the more electrical pressure or force. The electrical pressure of voltage is in the form of the attraction and repulsion of an electrical charge, such as an electron. Electric power expresses the rate at which an electrical device is converting energy from one form into another form. For example, LED converts electrical energy into light energy. The rate at which it does this is its power, expressed in watts. The symbol for watt is W. The power of a device is proportional to the amount of current flowing through it. It is also proportional to the voltage that is driving the current. The bigger the current and the bigger the driving force, the bigger the power. Writing this as an equation, Power is equal current into voltage. P is equal VI. Let's suppose we have 9 volt of battery and connected to 0.02 ampere rating LED. Then the power consumption of this LED will be 0.18 watt or 180 milliwatt.